Now, what I'm trying to do with these lecture notes is to give you at least one of every type of problem you, I think, are going to encounter in homework on this section. I could be wrong on that. I could have, maybe I assigned one that's not exactly like one of these, and I hope I did, because then that gives you more of a challenge. But basically, if you can understand your way through these, you've got it. Now, back on that other problem, we had to know what was given, what are we trying to find, and what are we going to use. Same thing's going to happen here. Okay, as you're writing frantically, I want you to pay attention to what we're talking about here. We're going to draw a picture. A plane flying parallel to the ground. Think about that. Don't write any more down. Just think about how would you draw that. A plane flying parallel to the ground. Okay, let's draw it. Here's my ground. You can't laugh. This is my airplane. It's the best I can do. That's my airplane. Okay. It's flying parallel to the ground. So it's kind of going in a line like that. Reasonable? Okay. At a height of 4 kilometers as it passes over a radar station. Here's the plane. It's passing over a radar station, so give yourself a radar station here. That first sentence tells you what else, though? Yeah, the height between the plane and, we'll say the ground, because we're really talking about the ground. That height is how much? 4 kilometers. Okay, so there's my image of what this initial problem is talking about. An airplane flying parallel to the ground passes over a radar station. At that point, it's 4 kilometers. A short time later, what direction is it heading? Well, maybe that's east. Okay, this direction, whatever direction that is. It's not. Is it increasing in elevation or decreasing in elevation? It's still flying parallel. Okay, so sometime later, maybe right over here, the radar equipment reveals that the distance between the plane and the station is now 5 kilometers. What do you draw to illustrate that? Yeah, otherwise known as a what? To the right triangle. Hypotenuse. Yeah, hypotenuse to the right triangle. And this distance is now how much? 5 kilometers. Okay. Okay, so that takes us to the middle of the second sentence. And that distance between the plane and the station is increasing at a rate of 300 kilometers per hour. Your derivative radar just went up, didn't it? Distance is increasing at a rate of 300 kilometers per hour. With those words, you know now that you're being given what information? Derivative of what? H? Is that what it says? It says the distance between the plane and the station, because the plane has moved a little bit. So the distance between the plane and the station is increasing at a rate of 300 kilometers per hour. At that moment, how fast is the plane moving horizontally? There goes up your next radar about derivatives. How fast is the plane moving horizontally? So what are you supposed to find? Well, V standing for what? No. I would hesitate to say that, Eric, because velocity is the or is the derivative of position, and I don't want to confuse that thought in anyone's head. You might, kind of, maybe, but no. Okay. If I'm horizontal, I'm horizontal on the ground, right? I'm looking at the distance on the ground. So it's my ground horizontal distance. All I can do is, I hate to do this to you, but I'm going to use an X. Okay. So you make up something. I would use H for horizontal, but I've got H for height over here. I don't want to confuse those two. So I'm going to use X. Now go back to that. But what am I trying to find? How fast is the plane moving horizontally? Now, I did it down here, but it's parallel, right? So the horizontal distance of the plane up here is the same as the horizontal distance of the plane down here. And I'm looking now more at a position. How fast is that position changing? So, yeah, derivative of x with respect to what? T. At what moment? Okay, so when d equals 5 kilometers, could be. Let's continue on and see what we got here. What are we going to use? Absolutely. Distance formula again, yeah. So we've got distance equals, and we know that's x minus x1 quantities squared plus y minus y1 quantity squared, and we've got that to the 1/2 power. But this is like the first problem, isn't it? Do we know a point? Now, if you look at that, it's like having the coordinate plane set up here. So do we know a point? Yeah, if this is my origin, right, then it's moved x units horizontally, and so I can use that as x. So using the horizontal, or using the origin, I'm going to say it's a derivative of x squared plus y squared to the 1/2. But instead of y, what did we use? H? Okay, so we used H. So I'm going to use H here instead. Well, if I'm finding the distance between this point and this point, and I know the formula is the square root of the coordinates of this point with the coordinates of this point's coordinates would actually be x, h, I'll put down, but we know it's 4, so x4. Okay. So yeah, and again, for h equaling 4, we know that, don't we? So this actually turns out to be x squared plus 4 squared, and then the square root of that. Okay, now, I've got to take the derivative of this. I'm trying to find dx dt. Well, let's just go ahead and do that. We've got derivative of distance with respect to time, so let's see what we've got here. This is what I assess you on. This is the new stuff you've learned, okay? Right here. How do you take that derivative? Yeah, so 1/2 x squared plus 16 to the negative 1/2 power times the derivative with respect to t of x squared plus 16, okay? Derivative of distance with respect to time equals Let's do it this way. 2 divided by x squared plus 16 to the 1/2 power. And this derivative is, and again, this is what I'm really going for, is your derivative work here. 2x times the derivative of the inside function. If you're still wondering how we're getting those, you've got a lot of work to do. I haven't decided when to have the next quiz. I want to get past all these makeups on the first test, so you've got a little bit of time here. But we won't stop forever, and the next quiz we have is going to have implicit differentiation. So be sure you can do that. Okay, so I'm trying to find dx dt, and what am I given? Okay, I've got that. But what do I also need to know in order to determine a numerical value of my answer? X. Well, let's see. Hang on a second. Yeah, you're on to it. Okay, we're multiplying here, so the 2's cancel. We got that. We've got x divided by the square root of x squared plus 16 dx dt. We're trying to find dx dt. We're told that it happens when the diagonal, the hypotenuse, that distance between, is 5 kilometers. Courtney? If this is 5 and this is 4, do you know what this is? Courtney's got a lot of voices. It's 3. Okay. You knew that. Okay. So x is equal to 3. So can I find dx dt here? Yeah. This is 300 equals 3 divided by the square root of 9 and 16 dx dt. Or dx dt is how much? Make sure it matches my answer here. Make sure I didn't do any errors, and because I do that sometimes. 500 what? Meters? That plane's flying awful slow. Kilometers, yeah. Per what? Hour? Okay. So when that plane is 500 or 3 kilometers away from the radar station, it is traveling 500. Its horizontal distance is changing 500 kilometers per hour at that point. Doesn't tell us how, what the horizontal distance is. We know that's not 500, but that's how fast it's moving. Okay. Again, going back on this, drawing the picture. I can't imagine not drawing a picture. I have to see these problems, these related rate problems, more than anything else. I've got to see a picture of them. Be able to come up with what is given, and what are you trying to find, and what are you going to use. Those 3 things will drive us. Yeah, Evelyn? Yep, that one I expect you to know. Okay? Okay, we're going to go on to the next problem.